Hey guys, I've had heaps of e-waste dropped off at the shop lately and I need to deal with it all. Now there's some interesting stuff. I've got to work out what I'm going to do with it. Some of it's quite vintage, some of it's not, but quite handy. This is a 13.8 volt DC power supply. The brand is a Panther. It's probably for like a power supply for a CB or UHF radio. I don't know if it works or not. I figured I might as well film everything. We'll work out what we're going to do. We'll test it. If it doesn't work, we'll see if we can fix it. If I don't think it's worth fixing, we'll scrap it. So we'll work out what's going on with it and we'll have a result one way or the other. So it's not really vintage, but then it's got a bit of age to it because it's got an older style plug without the protective sheath on the pins. Maybe it's 1980s, perhaps, maybe 90s. It's a model PS734 regulated power supply, 4 amp maximum, 13.8 volts DC regulated, Australian manufactured product, so that dates it a bit anyway. You don't find much made in Australia anymore. It looks in pretty good condition. It's got a couple of marks on the top. The cord's okay, but I'm a little bit sus because the front panel looks a bit bowed in. You can probably see in the reflection there, and the bottom of it, the front panel hasn't actually gone in the right notch in the case, which makes me think it may have been a part, because I certainly wouldn't have sold it new like that, and someone maybe have had it apart and hasn't put it back together properly. If it has been apart, what does that mean? It was maybe playing up and someone tried to fix it. I don't know. I think what we'll do for a start is we'll plug it in through my appliance tester. We'll see if we do get any life out of it, and if we don't, we'll inspect it, we'll pull it apart and have a look. Even if it does work, we'll probably still have to pull the case apart just to check it all and to put that front panel back in properly. I think it's worth fixing, or at least worth testing, because I'd probably price this at about $30 or $40 if it works, and I'll tag it as well. It's still going to have some use for anyone that runs CB radios or UHF radios, or something that needs a regulated power supply of around about 13.8 volts. So let's get our appliance tester out and we'll see what happens with it. We'll have to get our meter and see if we can get a voltage out of it. We've got an LED indicator light here, so hopefully something happens. Okay, we're plugged into the appliance tester. We'll earth onto the heatsink at the back. I think it's a class 1 product, so it should have an earth. Okay, we won't worry about the voltmeter just yet, and we'll see what happens when we switch it on. Okay, we have life. It tests okay. It has got an earth and it passes. We have an indicator light. Let's see if we have voltage. Hopefully the thing actually just works. That will make it quick. We'll just have to pull it apart and fix the front panel up. Okay, 20 volts. Oh yeah, there's DC. All right, what do we got here? Oh, we have 10.5 volts. So that's not a 13.8 output. What's going on with that? So I've left this thing running for a while and it's still consistently just over 10 volts, which I don't think's right. I think it should be 13.8. There's no load on it. It shouldn't have a low voltage. So I'm going to pull it apart and just see if we can find out what's going on inside. I don't know a lot about these things, but in my normal form, I am going to pull it apart and see. Interestingly, we still have a red glow on the indicator light, even though it's been unplugged. So I guess it's discharging a capacitor. But let's pull it apart and see what's going on. There's got to be some sort of fault with it, I would imagine. But whether we can find it is another story. And we've got 2 screws on the top, so interesting construction of the case. So what do we know? Well, we know that the indicator light works. I'm guessing the transformer's in good condition. Certainly if there was a windings problem with the transformer, I don't think we would have any voltage at the output. The rectifier part's working because we have DC voltage. So it's something to do with the regulator, voltage regulator. I don't know if it's got, I presume it's got filter capacitors in it, especially when you're operating two-way radios. You would probably want to keep the noise down. Alright, how do we get into this? I don't think there's any more screws. It must just clip on the sides. Oh, there we go. It does just clip. That's got it now. There we go. So we have a decent big transformer in there. Any wonder the thing was quite hefty. There are some filter capacitors on the board. It looks a pretty simple board. Oh, I can see something that looks a bit iffy. Hang on, I'll get it out and I'll show you. Let's get this panel out the front. There we go. Right, being careful what I touch, in case there is still some charge in the capacitors. We have a capacitor here, a little capacitor here that looks like it's blown its top. Alright, I think all the wires just solder, they don't plug in. I'll try and get some better access and we'll show you. I'll take it into my other room and we'll pull it apart a bit more. We'll test the capacitors with the ESR meter, but clearly we've got one there that needs replacing. Hopefully that's all the trouble is. Okay, we'll try and get better access here, but that capacitor is missing its head. Its entire top of it's blown off. Now, I didn't see any loose parts in here. There was certainly no remains of the capacitor floating around. So I think someone has had it apart and they've probably seen that and cleaned the broken bits out and then threw it into the e-waste because they didn't know what to do. Maybe, who knows. I'm going to take this as an aluminium board on the back of this circuit board. We clearly have to dismantle that to be able to solder a new part in, but I also want to test these filter capacitors, make sure they're okay. I'm not even sure what some of these other parts are. It looks like a bridge rectifier under there. That's some sort of adjustment potentiometer, probably a trim pot. It might be for setting the output voltage, but clearly things aren't going to work properly with that capacitor like that. So I'll pull the thing apart a bit more. We'll try and identify what part that was. I'm assuming it's probably the same as this one, but whether it's got part number or something still on it, there's nothing on that side. So I'm not going to be able to find a circuit diagram for this, I wouldn't expect. But I've got a couple of torque screws there which will take that bracket off, and that will allow us to slide this board out, I think. Oh, there's another one through this, whatever this is. So we'll pull the board out and we'll have a better look underneath it. Okay, we've got the screws undone. We can now move this plate away, and between this plate and the back of the circuit board was just a bit of cardboard to obviously stop the terminals or the solder points on the circuit board from shorting on the aluminium plate. The aluminium plate's really just a large heatsink, so we will have to put some more heatsink compound on there when we assemble it. I might look up the number of this component here and just see if we can test it. I should be able to test the diodes. Resistors will be easy enough to test. That's just a power resistor there. These capacitors are easy enough to test. I'm not sure what this is here. Maybe it's a fuse. Not too sure. We can certainly test it and see if it's got continuity or not. But yeah, this capacitor, we're going to have to try and find out what we can use there. There's no signs of any overload current. The back of the board looks alright. It does look rather homemade, and it looks like it's got a date here. I think it says GAF, and it looks like it says it finishes in 93, so I think that's a date, which would be around about right, 1990s, I think. Okay, so perhaps that's our only problem. As I said before, our rectifier is going to be okay. We had DC voltage, so we'll just check these caps, and I don't know what I'm going to do with that. I'll see if I can get a value off this one. They actually, oh yeah, they're not, they go to different parts of the circuit. I assume it's just some sort of, I don't know why it would cause the voltage to lower, unless it's got a partial short. That may do it, but normally a capacitance I wouldn't have thought will lower the voltage. It's probably more likely to be a filter of some sort. Okay, well, we might test it. We'll unsolder it because clearly it's no good, and we'll test it and see see if it has got a bit of a short, because that would certainly cause problems in the circuitry. Yeah, we should be able to get that component out now. Feels loose. Now, I don't know how we're going to go focusing here. There we go. That's all that's left of that capacitor. She really blew its top. It's a few weeks later and I really need to get this project off the bench, so I'm trying to work out what's going on here. I didn't want to just order another little capacitor. Incidentally, they're tantalum capacitors. I've been doing a bit of research and I've actually sketched out the schematic diagram from the board, and I'll tell you what, it's tricky to do. I haven't done much of this sort of work before, and even though it's only a little board and not many parts, it's really rather tricky to work out where they go. I was helped by finding through Google a very similar power supply using the voltage regulator, which I've discovered it is. It's an LM317T, which apparently are a very common voltage regulator, and the transistor on the back is basically to boost the voltage, I believe. It's a power transistor. So I've identified which capacitor it is that's blown, which is this one here. I can read the value off the other one, but I don't know if it's the same value or not. The circuit I found online was, I think it was 33 microfarad, which is a lot more than 4.7, but I don't think it makes much difference because it's only really across the output. So I'm guessing it's just to stop voltage ripple or just to smooth it out or some sort of filter. I'm not really sure what it does, but I'm fairly certain, even with this capacitor out of the circuit, which it does test open, so even with this out of the circuit, we should still have our 13.8 volts. So that leads me to believe that there's possibly a problem with the voltage regulator or the transistor. I need to work out how to test those two. I've tested everything else in the circuit. There's the three large caps are just filter caps. That's easy, they're fine. This one tested okay. All the resistors are okay. The diodes checked out fine. So that really just leaves these two semiconductor devices. I need to work out how to test, and I need to replace whichever is faulty, and I think one of them must be, because I'm sure, even though this guy's blown up, I'm sure it won't be causing our voltage drop. So, all right, I'll have to do some research and work out how to test those. A quick Google tells me how to test the transistor, and it's a matter of putting the meter in diode check, and the negative goes to the base, which is the red wire, and by touching the positive to the collector, we should get about 0.5 volts, and that's about right. And if we then go to the emitter, we should get similar. So that's good. Transistor's okay. So now we need to work out how to test this voltage regulator, and I think that's a little more complicated. Okay, I've been following some instructions from Google, and I've built myself a little resistor network circuit to test the voltage regulator. So this is a breadboard I bought ages ago and I've never used it. I'm actually enjoying mucking around with this and learning a lot more about electronics, and even sketching out that circuit diagram before is something I haven't really done before. So it's a big learning curve, this, and clearly the little power supply probably isn't worth it, but it is teaching me a lot, so it's worth it to me, and hopefully you guys might be learning a bit. So what we've done is we're applying 12 volt, in fact I think I've got 15 volts to the voltage regulator, and then through the adjusting component of that device, I've got a series of different resistances according to a circuit I found on Google for testing these things. And so instead of a switch, I just put a separate wire in here, and we can move from each resistor to another to give us different voltages. Now it appears to be working absolutely perfectly. If I move it up to the next resistor there, we have a lower voltage. If I move it to the next one, we go lower again, and so on and so forth. Now, the page I found this little diagram on, or this little test circuit, also gives you some formulas where you can actually calculate what your voltage should be, and it gives a chart at the bottom for these particular value resistors, and the voltages I'm getting are almost identical, slightly out, but then all resistors have a little bit of tolerance, plus or minus. So it appears that the voltage regulator is working fine. The first test was just to make sure it wasn't shorted, which was easy, but this second test actually proves that it is working. And even if I crank my power supply voltage up, apparently you can run it up to about 30 volts. The output voltage, I'm turning the power supply up now, and the output voltage is beautifully stable. Now we're up to 21 volts, and I can drop it right down to 12 now, and you can see the output voltage is perfectly fine. So I think that regulator is good. That means every single part on the circuit board appears to be okay except that capacitor. So my best guess now is that that capacitor blew its top because someone fiddled with the variable trimmer pot here. Possibly, maybe, it could have been a faulty capacitor, I don't know. But given that I don't think that capacitor really should influence the output voltage as far as dropping it from 13.8 down to 10 or something, it should not do that. I think someone, well, we know someone's been in here because that front panel wasn't installed properly. I reckon someone has been adjusting this trim pot, and possibly everything is fine. It just needs recalibrating up to 13.8. Now, clearly not everything is fine because we've got a deceased capacitor, but given that I think it just probably filters out some ripple, or I don't think it's integral to providing the 13.8 volts. So I'm going to reassemble this power supply now without that capacitor. We'll fire it up, we'll see what voltage we get out of it, and we'll try and adjust that trim pot and see if we can get up to 13.8. And I will order some tantalum capacitors, and I don't really think it matters what value, and we'll whack one in there just to complete the circuit. But I need to put this back together and be assured that we're going to get our proper voltage output first, so that's what's next. So I've finished soldering the parts onto the board. I haven't connected the heatsink to the voltage regulator because we're not putting any load on it, so it shouldn't get too hot at all. Of course, we haven't got the capacitor back in, it's blown its top. Everything else is back together. It's plugged in through the dim bulb, so let's fire it up. Okay, had a little flash on the bulb. It's probably just out of shot for you guys. Little flash on the bulb, and then it goes out, so that's good. It looks like we have the red LED on the front panel, so we've powered up. Let's see what voltage we have. And we have our 10.46, nearly 10.5 volts, which is exactly what we had when we started. However, I know a lot more about this circuit now than I did when I started. So everything appears to be okay, everything tested okay. And I suspect, as I explained before, that maybe we can just adjust the trim pot and we're good to go. So let's see if we can tweak any more voltage out of this with an adjustment on the trim pot. We can. I'm not sure how far it's going to go. I didn't turn it backwards. That's as far as it can go. 11 volts. Let's turn it back down. Okay, it goes down to 8.3, 8.29. And it only goes up to 11 volts. Why is that the case? Do we need a load on it for it to kick into 13.8? Has the transformer itself got an issue? This is puzzling. Okay, it's the next morning. I had programmed my subconscious to come up with a solution while I slept last night, and alas, it let me down. Well, I can't remember anything, so maybe it let me down. I've been going over and over this circuit diagram, and I'm glad I drew it out, actually. I'm learning a lot from this process. I've checked these main filter capacitors. I had to remove them from the circuit just to test them individually, just in case they had some sort of leakage and were pulling down the voltage from the transformer. They were all perfectly fine. I've checked and rechecked all the resistors, particularly these ones. That's the variable resistor, the trim pot, and that one's a fixed. And I figured if that one had some sort of drift from its proper value, it could upset things, because clearly altering that one alters the voltage. So I thought we'd make sure this one's spot on, and it was. That one was spot on. So all the resistors are okay. I rechecked the diodes in case they had some sort of leakage. Everything in the circuit turns out to be perfectly fine tested. I'm confident that the semiconductors are okay. So this morning I thought, let's just Google and see if you can replace a tantalum capacitor with an electrolytic. And I read that in most cases you can. So I pulled out a 10 microfarad 50 volt electrolytic. The voltage is more than required, so that's good. 10 UF, look, I looked at lots of these circuit diagrams while I was Googling yesterday, and the final capacitors were all sorts of ranges. I don't think it really matters. So I pulled out a 10 UF, soldered it in, and have a look at our meter. Oh, it's gone off. I must talk too much. We have 13.81 volts. I've just adjusted the trim pot. It's very precise. It varies the voltage beautifully, and it's very, very stable. So, blow me down. There we go. I have put the electrolytic capacitor, you can see it right in the middle there, in place of where that tantalum was. It's performing beautifully. There's no issues now with our voltage. I think this is a classic case of overthinking the problem. I guess one should have just lifted the lid, saw a blown part, replaced the part, tested it, put it back together, and there you go, problem solved in about 2 minutes. But no, I had to make a 25-minute video out of it or something like that. But, you know, it's been worth it because I've learnt a lot. I've done some circuit sketching. I've been Googling a lot of parts. I understand a lot more about this type of circuit now than I used to. So I think it's been time well spent for me. If anyone into electronics can explain why a capacitor just across the final voltage output affects the voltage, because it's DC voltage, and as far as DC voltage is concerned, a capacitor should be basically an open circuit. I don't know how that affects the voltage. It's not something I understand. But anyway, I guess the important thing is we now have 13.8 volts. I can put it back together and get it off my bench. Now, my channel is basically a how-to channel. I teach you how to keep stuff out of landfill. I teach you how to scrap stuff, how to repair stuff. But very much sometimes, especially with my electronics exploits, it's a matter of the blind leading the blind. Look, I don't mind that. It's learning for me. Hopefully you guys get something out of it. Any of you with more knowledge than me in given areas, which I'm sure there's plenty of you, feel free to add your comments, because we all learn that way by reading the comments. This job, successful. I'm very pleased to have it off my bench and fixed, and I can now test and tag it, put it in the shop and sell it, probably get $30 odd for it, maybe 35. That's not the point of the exercise. We've saved it from going into the e-waste stream. I've learnt a lot, and that's a good thing. I'm looking forward to the day when I can pick up something and say, I've done one of those before, I know what's wrong with it, instant fix, quick repair money. That day may never come because there's so much to learn, but I am enjoying the journey. This job was a little bit like going down to the shops to pick up some milk via Darwin. Now, most of you in Australia will understand that. Overseas, Darwin's a long way away. So anyway, job's done. I'm happy. We can get on to another project. Thanks for watching, guys. I'll catch you in the next video. Bye for now.